Hey everyone, welcome back to Data Sciencey. So, imagine a world where computers can solve problems a million times faster than today's most powerful supercomputers. A world where AI reaches superhuman intelligence. Materials can be designed at an atomic level, and cybersecurity is completely transformed. This isn't science fiction anymore. It's the promise of quantum computing, and at the heart of this revolution is something brand new: Microsoft's Majorana 1 chip. Now, this chip is a game changer in the race to build the most powerful quantum computer ever. So, what is this Majorana 1 chip and why does it matter so much? So, let's break it all down. So, here Microsoft few days ago has developed a chip called Majorana 1 chip, and this chip carves new path for quantum computing. So Majorana 1 chip is the world's first quantum chip which is powered by a new topological core architecture that it expects will realize quantum computers capable of solving meaningful industrial grade problems in years, not decades. So here this chip has the world's first topoconductor. Now this topoconductor is a type of material which can observe and control Majorana particles to produce more reliable and scalable qubits. Qubits are actually the building blocks for quantum computers. In the same way that the invention of semiconductors has made today's smartphones, computers, and electronics possible. So topoconductors and the new type of chip, which is Majorana 1, they offer a path to developing quantum systems that can scale to a million qubits and are capable of tackling the most industrial and societal problems which Microsoft has set. So we took a step back and said, okay, now this is said by Chetan Nayak, who's the Microsoft technical fellow. So he said, now let's invent the transistor for the quantum age and what properties does it need to have. And that's really how we got here. Now, it's the particular combination, the quality, and the important details in our new materials, the stack, that have enabled a new kind of qubit and ultimately our entire architecture. Now, the new architecture that they use, which is topological architecture, now this architecture was used to develop the Majorana 1 processor. Now, it offers a clear path to fill a million qubits on a single chip that can fit in the palm of one's hand. Now, in this chip, you can find million qubits, which is the building block for quantum computing. And they say that this is the needed threshold for quantum computers to deliver transformative real world solutions, like some real world solutions such as breaking down microplastics into harmless byproducts or inventing self healing materials for construction, manufacturing, or healthcare. Now, how we already know that all the world's current computers, which are operating together, can't do what a 1 million qubit quantum computer will be able to do. So, the topoconductor or the topological superconductor is a special category of material. Now, this material was actually used in Majorana 1 chip. So, this material, it can create an entirely new state of matter. So, it's not a solid, liquid, or gas, but it's a topological state. Now, this is harnessed or made to produce a more stable qubit that is fast, small, and can be digitally controlled. Because the regular qubits or the normal qubits that you find, it's not stable, it's unstable. But this, which is made by topological state, now this will make the qubit stable. For this breakthrough, it required developing an entirely new material stack which was made of indium arsenide and aluminium, much of which Microsoft designed and fabricated atom by atom. The goal was to coax new quantum particles called Majoranas into existence and take advantage of their new properties or unique properties to reach the next horizon of quantum computing. This Microsoft has set. Now, the world's first topological core, which is powering up the Majorana 1, is reliable by design, means it is error resistance, and the qubits in it are very stable. So at the hardware level, it is error resistant. Why qubits, the regular qubits, were unstable? They say like before, the qubits were unstable. Why was it? Because it was not error prone. Means from the surroundings, it would get errors and all that stuff. That's why it was not reliable and stable. So this new topological core is stable, so it's error resistance at the hardware level, so that's why it's more stable. Commercially important applications will also require trillions of operations on a million qubits, now which would be prohibitive with current approaches that rely on fine-tuned analog control of each qubit. Now, Microsoft Teams' new measurement, it enables qubit to be controlled digitally. So the qubits would be controlled digitally, in which it would redefine and vastly simplify how quantum computing works. Now, this process also validates Microsoft's choice years ago to pursue a topological qubit design. Today, the company has placed 8 topological qubits on a chip designed to scale to 1 million. So, because Matthias Stroyer, he said from the start, we wanted to make a quantum computer for commercial impact, not just thought leadership. We knew we needed a new qubit. We knew we had to scale. That approach led the Defense Advanced Research Projects Agency, DARPA, which is a federal agency that invests in breakthrough technologies that are important to national security, to include Microsoft. Now, they're including Microsoft in a rigorous program to evaluate whether innovative quantum computing technologies could build commercially relevant quantum systems, which is faster than the conventionally believed possible. So in addition to making its own quantum hardware, so Microsoft has also partnered with Continuum and Atom Computing to reach scientific and engineering breakthroughs with today's qubits. How at first they said that they made the material, which is topological superconductor, that material, and that material was used in their Majorana 1 chip. So with these two combined, the qubits achieve very stable. And if we talk more about qubits, so qubits are quantum bits which are analogous to the bits. So bits contains ones or zeros. So either it can be 1 or either it can be 0. But quantum bits or the qubits, it can have 1 or 0 or both. So it can have both also. So that's why it's called qubit. And one of the problem was that these qubits were unstable, but now they have made the qubits stable. Microsoft has made it. And with these qubits, they will be able to make a quantum computer which would be able to solve a lot of problems that a normal computer would take like more time, but a quantum computer would take less time to make it. So this is really a breakthrough. And the paper also says that Microsoft is not only able to create Majorana particles, so Majorana particles, it helps protect the information, the quantum information from random disturbance, but can also reliably measure that information from them using microwaves. So how Majoranas, the Majorana particles, they hide quantum information, which makes it more robust but also harder to measure. Now, the Microsoft Teams' new measurement approach is so precise it can detect the difference between 1 billion and 1 billion and 1 electrons in a superconducting wire. Now, which tells the computer what state the qubit is in and forms the basis for quantum computation. So, what do you think? Will the Majorana 1 chip be the breakthrough that finally makes quantum computers practical, or are we still years away from making it a reality? Let me know your thoughts in the comments below. And if you enjoy this video, do like, subscribe, and hit the bell icon so that you don't miss any updates from Data Science. Catch you next time. Bye bye.